A snail crawled across your face last night, and your skin looked better for it. Chuckles. That sounds like something your grandmother would say, but I'm about to show you the peer-reviewed dermatology research that explains exactly why Korean Snail Mucin is sitting on the shelves of some of the most serious skin clinics in the United States right now. I am Dr. Sandra Lee, your skin specialist, and if you have acne scars, active breakouts, or dark spots that nothing has touched yet, stay with me. Excited. This one is worth your full attention. What we call snail mucin in dermatology is a filtered biological secretion produced by the garden snail species Cryptomphalus aspersa. In nature, the snail releases this mucus layer when it experiences physical stress or environmental threat, and the purpose of that secretion is protection and tissue repair. The substance coats the snail's body and shell, preventing microbial invasion while accelerating regeneration of damaged tissue. Modern cosmetic science isolates this secretion through a process called snail secretion filtrate stabilization, where the raw mucus is purified, filtered, and standardized so the biologically active components remain stable and safe for topical human use. Inside this secretion is a very unusual combination of compounds that dermatologists normally use separately in different treatments. Snail mucin naturally contains glycoproteins that support tissue regeneration, hyaluronic acid that binds water molecules to the skin surface and improves hydration, and glycolic acid that gently breaks down the bonds between dead skin cells to support exfoliation. It also contains allantoin, a compound known for soothing inflammation and encouraging cell turnover. Trace minerals including zinc, copper, and iron are present in biologically useful concentrations. Copper peptides in particular are involved in enzymatic processes that influence collagen structure, while zinc plays a role in oil regulation within the sebaceous glands. What makes snail mucin scientifically unusual is that all of these compounds exist together in one naturally balanced biological matrix rather than being artificially combined in separate formulations. The Korean skincare industry was the first to successfully stabilize this complex mixture for consistent cosmetic use. Researchers developed filtration systems that remove impurities while preserving the biologically active molecules responsible for the repair response. The finished ingredient listed on product labels as snail secretion filtrate is therefore not raw mucus, but a standardized liquid extract that can be safely incorporated into serums or essences. This filtration process also ensures the concentration of the active compounds remains predictable across different batches, which is essential for dermatological reliability. The reason this ingredient began appearing in clinical skincare environments is because its composition supports several biological pathways involved in acne control, tissue repair, and pigmentation recovery at the same time. One of the ways snail mucin influences acne development is through antimicrobial activity. Acne inflammation is strongly associated with the proliferation of the bacterium Cutibacterium acnes within clogged follicles. Research has identified antimicrobial peptides within snail secretion that inhibit bacterial growth in laboratory settings. When this filtrate is applied to skin, it creates a microenvironment less favorable for bacterial proliferation. Zinc within the secretion contributes an additional effect because it regulates sebaceous gland activity. Sebum production is necessary for healthy skin, but excessive sebum creates the lipid-rich environment that allows acne-causing bacteria to multiply. By moderating oil production at the follicular level, zinc indirectly reduces the nutrient supply available to these microbes. Another relevant compound present in snail mucin is allantoin, which has mild keratolytic activity. Keratolytic compounds loosen the bonds between keratinized skin cells that accumulate inside the follicular opening. When those cells compact with oil, they form comedones, which are the plugs that become blackheads or whiteheads. Allantoin helps soften and loosen that buildup so it can be naturally shed through normal skin turnover. This process reduces the likelihood that follicles remain blocked long enough for bacterial inflammation to develop. Clinical observation supports these mechanisms. A study published in the Journal of Drugs in Dermatology in 2013 reported measurable reduction in inflammatory acne lesions in patients using formulations containing snail secretion filtrate over several weeks of consistent application. The second major pathway involves wound healing and structural repair following acne inflammation. When inflammatory acne lesions develop, they damage the surrounding collagen network within the dermis. If collagen loss becomes significant, the result can be atrophic scarring, which appears as shallow depressions or pitted areas on the skin surface. Glycoproteins present in snail mucin stimulate fibroblast activity in laboratory conditions. Fibroblasts are the connective tissue cells responsible for producing collagen and elastin fibers. Increased fibroblast activity encourages the gradual rebuilding of structural proteins that maintain skin thickness and elasticity. This mechanism parallels the biological function the secretion performs for the snail itself. When a snail's shell is cracked or damaged, the animal secretes mucin to assist with rebuilding the mineral and protein structure that forms the shell surface. The same molecular signals that guide this repair process appear capable of stimulating fibroblast behavior in human skin cells. Copper peptides present in the filtrate contribute further by activating the enzyme lysyl oxidase. This enzyme helps cross-link collagen fibers into a stronger network. Cross-linking is essential because collagen must form stable connections with neighboring fibers to restore structural integrity. Over time, this biochemical environment can gradually improve the appearance of shallow acne scars by strengthening the dermal matrix beneath the skin surface. Snail mucin also influences dark spots, particularly the type known as post-inflammatory hyperpigmentation. One mechanism involves the presence of naturally occurring glycolic acid within the secretion. Glycolic acid belongs to the alpha hydroxy acid family and functions by dissolving the adhesive bonds that hold dead cells together on the outermost layer of the skin. When those bonds loosen, the older pigmented cells detach more easily and are replaced by newer cells from the lower layers of the epidermis. This process accelerates normal cell turnover, allowing discoloration left behind after acne lesions to gradually fade as fresh skin emerges. The concentration of glycolic acid in snail mucin is relatively low compared with dedicated chemical exfoliating treatments. That lower concentration is important because it allows gradual surface renewal without the irritation commonly associated with higher strength exfoliating acids. Many individuals with sensitive or reactive skin cannot tolerate direct application of concentrated glycolic acid products. Snail mucin provides a gentler pathway to mild chemical exfoliation because the acid exists within a hydrating biological matrix that reduces the likelihood of barrier disruption. For patients prone to redness or dryness, this balance can allow progressive brightening while maintaining skin comfort. Inflammation also plays a central role in pigmentation development. After the skin experiences injury or inflammation, specialized cells called melanocytes increase melanin production as part of a protective response. This melanin can accumulate unevenly in the epidermis, producing the dark marks that remain after acne resolves. Allantoin helps interrupt this pathway because it reduces inflammatory signaling within the skin. By calming the inflammatory cascade earlier in the healing process, the stimulus that activates melanocytes becomes weaker. When the inflammatory trigger decreases, melanin production is less likely to exceed normal levels, which helps limit the severity of post-inflammatory hyperpigmentation. This mechanism explains why snail mucin often performs differently from traditional brightening serums that focus only on inhibiting melanin synthesis after pigment has already formed. Instead of targeting pigment alone, the ingredient addresses the inflammatory environment that initiates excessive melanin production in the first place. Clinical observations have shown that patients with deeper skin tones, particularly Fitzpatrick skin types 4 through 6, can experience gradual improvement in post-inflammatory hyperpigmentation with consistent snail mucin use over approximately 8 weeks. Because deeper skin tones are more prone to PIH following acne inflammation, ingredients that calm inflammation while supporting regeneration can be particularly valuable in those populations. Certain groups of patients tend to benefit most from incorporating snail mucin into their routine. Individuals with acne-prone skin often appreciate its combination of hydration and mild antimicrobial activity. Patients who are recovering from acne lesions and want to improve the appearance of lingering marks or shallow scars may also find the regenerative properties useful. The ingredient can also benefit people experiencing dehydration or sensitivity because hyaluronic acid and glycoproteins reinforce moisture retention without introducing strong exfoliating acids or retinoids. Dermatologists sometimes recommend gentle regenerative ingredients during periods when the skin barrier is recovering from irritation or clinical procedures. Because snail mucin does not rely on aggressive chemical exfoliation, it is considered relatively safe during barrier repair phases. However, certain precautions still apply. Individuals with known allergies to mollusks or shellfish should approach this ingredient carefully because cross-reactivity between proteins is possible. Performing a patch test on a small area of skin before widespread use is a sensible precaution. Pregnant patients generally tolerate snail mucin well because it lacks systemic absorption and does not contain retinoids or high-strength acids, but medical professionals typically advise discussing any new cosmetic active with an obstetric provider before beginning regular use. It is also important to clarify that snail mucin is not a replacement for prescription therapy in severe cystic acne. Nodular or cystic acne involves deeper inflammatory processes that often require oral or prescription topical medications to control bacterial colonization and hormonal triggers. In those situations, snail mucin can function as a supportive product that improves hydration and supports healing, but it should not be expected to control severe disease on its own. Setting realistic expectations prevents disappointment and helps patients understand where cosmetic skincare fits within broader dermatologic treatment strategies. For individuals who decide to incorporate snail mucin into their routine, concentration and formulation matter. Products designed for therapeutic benefit usually contain snail secretion filtrate concentrations around 96% or higher. This means the majority of the formulation consists of the active filtrate rather than filler ingredients. The ingredient should appear within the first few positions on the ingredient list, according to International Nomenclature of Cosmetic Ingredients Standards, which lists components in descending order by concentration. When the filtrate appears far down the ingredient list, the actual amount present may be too low to produce meaningful biological effects. Serum and essence formulations tend to deliver the ingredient most efficiently. These products are typically water-based and have lighter viscosity, which allows the hydrophilic compounds in snail mucin to penetrate the upper layers of the epidermis more easily. When the filtrate is placed inside thick cream formulas containing heavy occlusive oils, those oils can form a barrier that limits how much of the water-soluble component actually reaches the skin surface. This does not mean cream formulas are ineffective, but they may reduce the bioavailability of the active compounds compared with lighter formulations. In practical routines, snail mucin is usually applied after cleansing and toning while the skin remains slightly damp. Damp skin improves absorption of hydrophilic ingredients because water facilitates diffusion through the outer layer of the epidermis. During morning routines, the serum or essence can be applied before sunscreen because snail mucin does not increase photosensitivity. Unlike stronger exfoliating acids, it does not thin the outer layer of the skin significantly, which means it remains safe for daytime use when combined with appropriate ultraviolet protection. At night, the ingredient can be applied before moisturizer, so the glycoproteins and hydrating molecules remain in contact with the skin during the hours when repair activity naturally increases. The filtrate generally combines well with other supportive ingredients, including niacinamide, hyaluronic acid, and ceramides, because these compounds strengthen barrier function and regulate oil production. However, layering it simultaneously with strong alpha-hydroxy or beta-hydroxy acids may increase irritation because the mucin already provides mild exfoliation through naturally occurring glycolic acid. Retinol can still be incorporated in routines that include snail mucin, but application order matters. Retinol is lipid-soluble and should typically be applied first to clean, dry skin so it can penetrate efficiently. Waiting approximately 10 minutes allows the retinol to absorb before applying the hydrating mucin layer on top. This layering approach avoids diluting the retinoid while still allowing the soothing compounds in the mucin to support barrier comfort. Understanding absorption principles helps ensure each active ingredient performs its intended function. Results from snail mucin develop gradually because the ingredient works by supporting biological repair rather than forcing rapid exfoliation. During the first 1 to 2 weeks, most individuals notice increased hydration and softer skin texture as hyaluronic acid binds water to the surface and allantoin calms irritation. By the 3rd or 4th week, some reduction in inflammatory acne lesions may become visible as antimicrobial peptides and zinc influence bacterial growth and sebum production. These changes tend to appear subtle but measurable with consistent use. Between 6 and 8 weeks, many patients observe gradual fading of post-acne dark spots as the mild glycolic acid content increases cell turnover, while anti-inflammatory compounds reduce ongoing pigment stimulation. Structural improvements in shallow atrophic scars typically require longer time frames. Collagen synthesis and remodeling occur slowly, and visible improvements in texture may begin to appear after 3 to 4 months as fibroblast stimulation and copper peptide activity strengthen the dermal network. Deep ice pick scars remain difficult to correct with topical skincare alone, and usually require in-office procedures such as microneedling or laser therapy. Several common mistakes prevent people from seeing the full benefit of snail mucin products. One frequent issue is purchasing products where snail secretion filtrate appears very low on the ingredient list. When the concentration is minimal, the biological effects described in clinical research become unlikely. Another mistake is expecting visible results within the first 2 weeks and abandoning the product prematurely. Collagen remodeling and pigmentation correction both require time because they depend on natural skin renewal cycles. A third mistake involves combining snail mucin with multiple aggressive exfoliating acids in the same application. Because the filtrate already contains glycolic acid, layering additional strong acids can overwhelm the skin barrier and cause irritation that actually worsens pigmentation. Finally, many patients forget that ultraviolet radiation stimulates melanocytes directly. Treating dark spots without daily sunscreen allows ultraviolet exposure to reactivate pigment production, reversing progress achieved through skincare. Snail mucin represents one of the more versatile ingredients currently used in cosmetic dermatology because it supports antimicrobial control, hydration, inflammation reduction, and tissue regeneration simultaneously. When incorporated into a consistent routine alongside sun protection, it can produce measurable improvements in acne recovery and post-inflammatory hyperpigmentation within 6 to 8 weeks. If you are currently dealing with breakouts, lingering dark spots, or both concerns at the same time, I would like to know which one you are trying to treat first. So leave a comment below and tell me what your skin is struggling with right now. Share this video with someone who is still dealing with marks left behind by acne, and subscribe if you want clear, science-based explanations of the ingredients you are putting on your skin every day. I am Dr. Sandra Lee, your skin specialist. Take care of your skin tonight, and I will see you in the next video.